In the last class, I have told about the theory about the complete theory about the VCRS. So that's why today we are going to solve the numerical on the vapor compression refrigeration system. So that's why I want to know how many of you are there that time. Accordingly, if most of the people are the first time here, so quickly I can tell the formula at least, so that while solving problem you can try. So today we are going to solve only problems. So keep calculator along with you. So first I told about the this all four components about the system, and then the COP about of the system that we can find by refrigeration effect by work input. So this is the formula we will be using: H1 minus H4 by H2 by H2 minus H1. And next I told about the volumetric efficiency of the reciprocating compressor. So today we are going to see one numerical on the basis of that. So that we'll see. So these two formulas are very important, so that we will be seeing while solving the question. And these are the some effects of various parameters on the performance of the cycle. Next, isentropic efficiency, that is simply we are going to see for the compressor. It is the theoretical work that we are going to give, and that is the what actual work we have given to the compressor. So one numerical we are going to see about the regenerative heat exchanger in VCRS. So that numerical we will be solving. Here most important thing is like here degree of supercooling is not equal to degree of here heating. It is the amount of heat that would be the equal there. So keep that in mind while solving the problem. And next this is the can anyone tell what is this?
Cascade systems.
So this is the cascade refrigeration system. So might we today we are not going to see the problem on basis of that. So next class we would be solving one problem on that, and then we switch to next set of the things what I have given there. So this is the efficiency formula for the overall COP formula for the overall cascading system in the form of COP of the individual system. So if anyone have any doubt in the last class, can quickly ask, then we will switch to problems. If no one is having any doubt, so we will be switching to the problem. Actually I used to upload the video recording just after the class. Might be in the website they are uploading a bit late, but I used to upload there quickly. So in website, if it is not there, you can see from here. I can show. You most probably you won't be getting from the as of now. In phase 1, if you go there, you can get the YouTube channel. That channel you can easily get. So if you in the phase 1, if you will see, if you select here mechanical, so in the Monday side, because last time I was taking class on Mondays, so here this recording link will take to you YouTube channel. There you can find the RAC one playlist. So there you can you will be getting the lectures.
Sir, can you show once, please?
Okay, 1 minute. I can quickly show. Okay, from here only I will go. This is for the thermo. 1 minute.
The term due
Here two lectures I have uploaded. This you can see RAC1, RAC2. Okay.
Yes, sir. Got it, sir. Thank you.
There you can get. Okay, so for today we are starting.
So the important formulas are COP and then volumetric efficiencies.
What are you saying?
For today's session calculations,
Uh-huh.
you have to about the important formulas, right? Sir?
Yeah. Because generally formulas are not required. You have to just basic concept you have to use, but keep in mind those two formula. 1 minute. I will show again. So these two, keep the screenshot of that along with you, and this two formula would be useful there.
Sure, if you just give a very brief of what we'll be solving, it will be useful for solving today's.
Yeah. It would be better if we directly see in the problems. Here it would be that much clear actually.
Okay, sir.
Okay. So initially we would be solving to some light problems. Then it will come. Okay. Okay. Then first read this question and then try to solve in 1 minute. 1 minute I will wait and then we'll start. This is the some basic problem you have to try. Okay, I will be waiting for 1 minute, and whoever answer is ready, so can you let me know? Okay, first of all, how many of you are not able to solve this problem? Can you raise hands? Okay. So what is given here? A 5 kilowatt loading capacity refrigeration system working on simple VCRS. So what is this 5 kilowatt? Can anyone tell?
Refrigerating effects.
Refrigeration capacity or refrigeration effect. This is given as 5 kilowatt to us. So refrigeration effect is 5 kilowatt, and refrigerant enters evaporator with the enthalpy of this. Means we will make simple VCRS cycle on TS diagram. So it is saying like refrigerant enters evaporator entry is this. So here it is entering as the 75 kilojoule per kg. It is the enthalpy of this point, and it is leaving the evaporator at the 183 kilojoule per kg. So enthalpy of this point is 183 kilojoule per kg, and after this it will enter to the compressor. So at the discharge of compressor, entry is this, so entry is this point only, so discharge would be the isentropic compression would happen, and this point discharge is there from the compressor. So this enthalpy is 210. So after this it will go to the condenser, and then it will come here only. So this point enthalpy is not given. Can anyone tell what would be this?
75.
75. It would happen because here the throttling process will happen in the expansion valve. So this point and this point enthalpy would be the same. So now we are knowing all the enthalpy of all 4 points. So we can easily find the COP, power consumption, and heat rejection in the condenser. So what is the COP? Can anyone tell the formula? Let's suppose this is the first point, this is second point, this is third point, and this is the fourth point. So in terms of enthalpy, what is the refrigeration effect here?
H2 minus H1
And
divided by H3 minus H2.
okay, so we are knowing the enthalpy of all points. We can put here what is the H2? 183 minus 75 by 210 minus 183. So when you solve, what would be the answer?
4.
Anyone, any other person who has solved? How many of you found the answer 4?
Yes, sir. 4.
Okay. So after that, in order to find the power consumption, what is the required thing? What you will find first? Can anyone tell?
Mass flow rate.
So have anyone calculated what is the mass flow rate?
0.046 kg per second.
0.046 kg per second. Anyone getting other answer or same?
Same answer.
Okay. So mass flow rate, how will you find? We know the refrigeration effect in kilowatt, and we know the refrigeration effect here. What would be the unit of this? 1 minute. Refrigeration capacity we can find. What is the refrigeration capacity? H2 minus H1. So when we'll calculate this, it will become how much? 108. What is the unit of this?
Kilojoule per kg.
Kilojoule per kg. But we want this answer actually, sorry, we requires the power input here. Power input we are giving in the compressor. This is not this, sorry. What is the power input? Power we are going to give in the compressor. So first we are going to find the work input, and then we'll convert that to power input. Work input is H3 minus H2. So this will become 210 minus 183. How much it will come? 27 kilojoule per kg. But we don't know the mass flow rate. This mass flow rate we can get from here. What is the refrigeration capacity, and divide by this whole kilojoule per kg. So in order to find the mass flow rate, we will find the refrigeration capacity. We'll find this first. So it will become 183 minus 75. It will become 108 kilojoule per kg. And this we know the refrigeration effect is, this is refrigeration capacity, and refrigeration effect is 5 kilowatt, or kilowatt we can write as a kilojoule per second. So we can get the mass flow rate as refrigeration effect by refrigeration capacity. So refrigeration effect is 5 and this is 108. Then we will see the kilojoule will cut and it will come. Same thing will come, right? Hello?
Yes, sir.
Okay, so from here mass flow rate you can get, and third is the heat rejection in the condenser. So heat rejection in the condenser is what? How much? What is the AQ rejection in the condenser? It is the H3 minus H4, right? But if you have to tell that in kilowatt, so here also you have to multiply with m dot. Is it clear or not? If anyone having doubt somewhere, tell me. I will again tell, and because it is the just start, so some doubt might be here. Hello.
Sir,
Yeah.
you can find power consumption by COP equal to desired effect by work input.
Same way you also can find. Yeah.
Okay.
I think same answer will come.
Yes, sir.
So what is the power input here? It is coming.
6.21 kilojoule per second.
Power input is what? 6 point.
Heat reduction condenser, sir.
No. Power input to the compressor. What is the answer in kilowatts?
1.25.
1.25 kilowatt. Yeah. It will come the same when we do the power input is the refrigeration effect by COP. When we divide this, I think 5 by 4. So same will come. So when we find this QC is equal to S3 minus H4 into m dot, what will come? Can have anyone calculated?
6.21, sir.
6.21.
Kilojoule per second.
Okay, kilowatt also. Has anyone calculated also same answer?
Same answer.
Okay. So all others, is it clear or not? First, only one thing is required. You need to have the clarity of the VCRS cycle only. What is the first 1, 2, 3, 4? After that, I think everything is given here. Just simply you have to calculate. Okay. So 1 is the entry to the evaporator, 2 is the exit of evaporator and entry to the compressor, and the 3 point is the exit of compressor and entry to the condenser, and 4 is the exit of condenser and entry to the expansion valve. So these 4 terms should be very clear. Okay. Okay, should I switch to next problem? Or any doubt is there, then quickly let me know. I will clear.
No problem.
Okay. Okay, try this question. I am reading. Temperature limit for ammonia refrigeration system is this is the condenser temperature. It is given. This is the evaporator temperature -10. Gas is dry saturated at the end of the compression. So this is important thing. Gas is dry saturated at the end of compression. First we have to find the COP of cycle, and no undercooling of ammonia is done. This is the these are the properties given here. So I will wait for 1 minute and try. Then I will start and ask the values with you. If anyone will solve quickly, then he can say like I have done. Anyone solved?
Solving, sir.
Okay, simultaneously I will solve. So if some error is there, you see. So here temperature limit for ammonia refrigeration system is 25 degrees Celsius and minus 10 degrees Celsius, and gas is dry saturated at the end of the compressor. Find the COP of cycle. So here we have to find the COP, and no undercooling of ammonia is done. So can anyone tell where we are going to do undercooling? Means for which part it is saying no undercooling is done?
Condenser output.
So it is saying like when it is exit of the condenser, so exit of the condenser fluid is the saturated liquid only. Okay, so its meaning is this, right? Hello.
Yes, sir.
So TS diagram will draw. So one limit is given as 25 degrees Celsius and another one is minus 10. So here it is the gas is dry saturated at the end of the compression, means here end of compression means entry of the condenser. So this is the dry saturated, means if isentropic compression will happen, then it will come here only. So this point is second point. Second point is the exit of the evaporator, and here it is given no undercooling is done, means this is the third point and this is the fourth point. So fourth point would be the saturated liquid. Is it clear why fourth is saturated liquid?
Yes, sir. Yes, sir.
And third is also clear why this is third. So now we can easily get the first point. First point would be here somewhere, and this is the second point. So we know the properties of third point and we know the properties of fourth point. We don't know property of first and second. So we have to find the COP. So in COP we need to find the all enthalpy values. So here what we know is H3 we know, right? What is H3? Can anyone tell? Sorry.
1465.84 kilojoule per kg.
Minus 10, this is 25. So H3 is the saturated vapor at the 25 degrees Celsius. 25 degrees Celsius saturated vapor. So this value would be the our H3. So what would be our H4? This would be our H4, right? Hello.
Yes, sir. Yes.
And what would be the H1? Same, H1 would be the same as H4, right?
Sir.
So what is remaining there? H1 sorry, H3 is 1465.84 and H1 and H4 is 298.9. Now H3 is remaining. We don't know about H3. How can anyone tell how we can find H3?
From second law of thermodynamics. ds Ps equal to dq by t.
Okay, then how you will find? 1 minute.
dq h of j by t saturated, sir. Change in entropy equal to.
What will you do here? Okay. Have you calculated? You calculate that way. How you will calculate? Tell me. I don't think that way you can calculate here. What are you saying? ds is dq by t, right?
Yes, sir.
Okay, then what is dq, what is t here? T we can say this, okay, fine. 263. Then what will you do here?
dq h of plus x h of p, sir.
This you are saying.
Yes, sir. To find the drainage fraction.
1 minute. Okay, these two values you know, so okay, fine. These are the two values. Something you will be getting here. Then what you will get here from here as fg you will be getting, right?
Yes, sir.
So okay, after that what you will do? What is SF? What is SG? How will you know? Are you getting what I'm saying?
Yes, sir.
But here you know this value. What is this? This is the SF, right? SF you knows. SG you can you calculate?
Yes, sir.
Okay. So what is this value? Can I have anyone calculated? What is HFG for this? Minus 10 degree. What is the HFG for minus 10? Has anyone calculated? What would be the value of this? 1433.05 minus 135.37. Right? This minus this. Am I clear or not?
Yes, sir.
This value minus this value. What is the value is coming?
One,
One
two, nine.
1.9.
One person can tell. 1, 2. Hello.
1297.68
68.
kilojoule per kg.
Okay, fine. And then divide by this 263.
270 in Kelvin, sir. Minus 10 degrees centigrade in Kelvin.
263. Na? So what is this coming?
Uh, 4.93.
Is it for everyone, right?
Yes, sir.
Then we know SFG here, but we know only SF from here. So SF minus SG is this 4.93. So can you tell what is SG?
1.124, sir.
I think something I missed. This is wrong. SG minus SF, right? So SF will come here. So it will add in 4.93.
5.48.
5.48. In 4 digits, can you tell?
What's up?
In 4 digits. After decimal, 4 digits you go.
5.4784.
1 minute. 4784. Okay. Now we know the SG value for this. This is the SG value. And SF we already knows. So H2, what will be the H2? How can you find now? Because it is required, right? SFG we are requires, SGV requires, then only we can find the this value. Because now we know the S3. Do you know S3?
No.
No, sir.
That also need to be calculated, right? So what would be the S3? First tell that.
Yes. S2 equal to F3.
Actually, this is the problem where you will be getting all type of problem. Okay. So you need to think. That's why I am giving time. So first let me know how will you calculate S3, then we'll start. Okay. Anyone know any idea?
Same as we did for
So
from
tell
1
the
to
value.
2.
What is the S3?
S3 at 5.0.
So you can get 1465.84 minus 298.9 divided by 298, right? 298 would be means Kelvin in this. So this would be the HFG. This is HG and this is the HF. So Hg minus Hf, this would give HFG for the this temperature, and divided by the temperature would be the it would be S3 minus S4. So S4 we are knowing, this is the S4, right? This is entropy of liquid, means entropy of liquid is this. S4 we are knowing, so this is the S3 minus S4. So S4 value we knows, and this would be coming some value. How much this is?
3.91.
3.916. Okay,
Hmm.
so S4 we are knowing as 1.1242. So what is the S3?
5.04.
5.04. Okay, now we know the S3, but okay, so S3 we knows, and here isentropic compression happened, so we know the value of S2 also now, right? S3 is equal to S2. Clear or not? Hello, why S3 is equal to S2? Is it clear or not? Let me know. If anyone is not clear, I will repeat again whole solution, but as of now tell what S3 is equal to S2 is clear or not.
Sir, could you please repeat it?
Because what happened from here, evaporator entry, it is evaporator exit, and here it will enter to the compressor. In compressor what happens? Isentropic compression, right? So entropy would be constant along the process. 2 is the entry, 3 is the exit, and the entropy of 3 we knows. So entropy of 2 and entropy of 3 would be the same, right?
Yes.
So that's why we found the entropy of 3, and it would be the same as entropy of 2, correct?
Yes.
So we know the entropy of second point now, but we need, in order to find the COP, we need to find the enthalpy of the third point. Sorry, second point. We know the enthalpy of 3, 4 and 1, but we don't know the enthalpy of second point. So entropy of second point we know. How will you find the enthalpy of second point? Can anyone tell?
Finding the dryness fraction.
So
H plus HH is.
yeah, find the dryness fraction. How will you find? So it would be the S2 is equal to, for minus 10 temperature I am writing, okay? S2 is equal to SF plus x of 2 I am writing, because dryness fraction at the second point I am writing, okay? X2 minus, sorry, into SFG. So S2 we are knowing as 5.04. SF we knows, SF is this. So SFG we knows also, SFG here. This is SFG, right? 4.93. So let me know the value of X2. What is X2?
Point 9111.
0.9111. Next. Okay, fine. 4 digit. Okay. So X2 now we knows. If you know the dryness fraction, then you easily calculate the enthalpy of that point. So what would be the H2? This would be the HF plus X HFG, right? So X we also knows now. This is the X, and HF is this, and HFG is this 1297.68. Or you can minus this. This will, you will get this one. So what is the H2? Can anyone tell?
Mm. 1317.68.
1 minute. What you said? 1 3
17.68.
Yeah, kilojoule per kg. So now we know the enthalpy of all 4 points. Okay, correct. What would be the COP formula? With this, can you tell?
H2 minus H4 divided by H3 minus
H4 or H1? Generally say H1 because refrigeration effect we used to see here. H4 you have to go there. Value is same, but H2 minus H1 is okay, right?
Okay.
H2 minus H1 by H3 minus H2, right?
Yes, sir.
So this is the refrigeration effect, and this is the work input or power input. So we know all the values H1, H2, H3, H4. So what is the H2 minus H1? Can anyone tell? Means refrigeration effect. What is the value for that? Hello.
1182.
What?
1182.
1182. Is it for others?
I am getting 1018, sir.
I think it is
1018.
it is wrong, right? 1018, right? What is the power input? H3 minus H2. H3 is this, and H2 is what we have calculated here. This is H2. H2, H3. What is the difference? Have you got what is H3 by H2? H3 is this, H2 is this. Simply subtract it.
1177.97.
1
77.
How you are getting this much?
I'm getting different answer.
You have to subtract 1465.84 minus 1317. So it would be close to 100 only, right? 100 or 100, 450. What is this? How much?
148.
Yeah, close to 150. Yeah. How much? 148 point. Exact 148.
I approximated it as 148.
Okay. So it would be 148, right? H3 is this, and H4, H2 is this, 1317, and this is 1465. So 148 approximate would be. So what is the COP? Divide it.
$6.87.
It would approximately to 6.87. So what you have learnt in this question actually? Question answer would come anyhow, but what you have learnt, that is important. So here you have got, if you have given some less data, so that data you have to know how to calculate. Okay. So here what you have given only, here only entropy of liquid you have been given, right? But everywhere you have to found the what is the entropy of the saturated vapor. How you calculated? We know the latent heat. Heat is what? Saturated vapor and saturated liquid. The difference of that would be the latent heat, and we divide it with the saturation temperature. So that would be the SFG, and SF is given, so SG we have calculated, right? Hello.
Yes, sir.
Is it clear to everyone or not? Question is not tough, but concept should be clear for that. Because actually we are going to see the same problem again, but in different way. So you have to be prepared for those. That's why I did this initially. Is it clear? Or I tell whole solution again?
Sir, at the drainage fraction, how to get the drainage fraction
Ah,
at that point?
okay, dryness fraction, is it clear to you how this S3 is equal to S2?
Yes, sir.
Okay, so this S3 is equal to S2 because this is the isentropic compression. But how you usually find the this point entropy now you knows, but you don't know what is the dryness fraction for this. How you know the dryness fraction for any general process? There you need to find the end point of that line. This is the one end point, and another one is end point is this, right, along that saturation line. Let's suppose this is the saturation line. So we know the value of this, but we don't know the value of this sg value we don't know. So sg we have calculated from here, right?
Yes, sir.
sf we know, now sg we also know, but and we know the value of this point. So simply we can find the dryness fraction of this point. Do you know the formula, or I need to tell how this formula has came? Hello, you know this formula, right?
Yes, sir.
This is simply linear interpolation or nothing. So that linear, because you divide this whole line as 1, and what is the difference this much, so convert that difference to 1. So what is the value of that value there? Simply that we have did, right? Then dryness fraction you usually calculate that way, right?
Okay, sir.
So this is the formula x you have found from here, and enthalpy found the enthalpy of this point. Okay, so should I go to next problem?
Yes.
Yeah, here it is given, right? sf is also given, and sg is also given. So here that much difficulty won't be there. So try to solve it. I will draw the cycle, and then you try. A refrigerant based on the ideal VCRS they have written. So operates between the temperature limit of -20 and 40. So this is the limits are there. So refrigerant enters the condenser as a saturated vapor. Similar problem to last time, right? So here also refrigerant enters the as a saturated vapor. So this point would be the third point. So second point would be somewhere here, right? And refrigerant enters the condenser as a saturated vapor and leaves condenser as a saturated liquid. Same last time. Here it will leave, and this would be the first point. Enthalpy and entropy values are given here. So here simple, it is the simple problem. So last time, if last problem you would have understood, then this problem you can quickly can do, right?
Sir, enthalpy 1 HF and 1 Hg, na?
What?
Enthalpy given 1 HF and 1 Hg.
Oh, sorry, yeah. This is G, right? Now we know the value of H3. What is H3? Can anyone tell?
200.
And what is H4? It is similar to H1. So need to find H2. But how to find H2?
H2.
So
HF plus.
No. First you have to find the dryness fraction of here, right? How you can find the dryness fraction? Because it is isentropic compression, so S3 would be equal to S2. This is the same, follow the pattern what I did last time. If you need to find here H2, then you have to this entropy would be same. So you would be knowing the entropy of here, and then this entropy end point entropy is SF and SG you knows. Then find the dryness fraction of here, then find the enthalpy, right? This pattern you have to follow. So S3 is equal to S2. This is the 0.7366 and sorry, this value, right? Not this. This is for minus 20 degrees Celsius. For 40 degrees Celsius you have to take the saturated vapor value. So 40 degree is this bottom one. So this is the 0.67. So S2 is equal to SF plus X SFG. So SF value is what? How much SF? This is the SF, right? For 20 degree minus 20 degree. And what is the SFG? You have to take the difference of this SG minus SF, then SFG would become. So can you tell what is the X you are getting from here?
0.9, sir.
Only 0 or some other value after 0.9?
0.00.
Oh, okay. Is it same for others?
Yes, sir.
Okay. Now you have found the dryness fraction of for that. So enthalpy, can you tell what is the H2? H2 would be what? HF plus X HFG. So you know everything. HF also, X also, and HFG also you know now. So what is the H2?
164, sir.
Is it correct, right?
Same answer, sir.
Okay. So what would be the COP? H2 minus H1 divided by H3 minus H2. So 164 minus 80 divided by 200 minus 164. So how much you are getting from here?
2.33, sir.
2.33, yeah. So what is the refrigeration effect if mass flow rate is this? Then for second problem, refrigeration effect. What is the refrigeration effect? Means m dot H2 minus H1, right? Mass flow rate is given. H2 you have calculated here. H1 already knows. H1 is what? H1 is this. Simply you can find, right? What is this?
2.1 kilos.
How much value? 4 point?
2.1, sir.
Is it for same for others?
Yes, sir.
Okay, 2.1 kilowatt. If any doubt in this problem, if you have understood previous problem better, I think previous problem is more difficult relative to that. It is not difficult, only it here no entropy value for vapor is given, and here this value is also given, so it is relatively easier. Otherwise same problem, right?
Sir, previous slides.
Previous one is this. Say both are same problems I'm saying, and here more effort you have to give. Here you need to know like how some missing values are there, then how to tackle the problem. Okay. So should I go next slide?
Yes, sir.
If anyone is having doubt, let me know. Okay. So first read and let me know which type of problem is this first. Then try. Then I will solve. You just let me know in between what to do next, what to do next. Other only then you will get like okay, which type of the problem is this. So I'm reading. So I will ask in between what you have got from here. So one is food storage requires a refrigeration capacity of 50 kilowatt. So they have given the refrigeration effect of the 50 kilowatt, and it works between the temperature limit of -10 and 35 and NH3 as a refrigerant. So temperature limit it is given as this. So now it is subcooled by, read this line carefully, okay. It is subcooled by 5 degrees Celsius in a heat exchanger before entering the expansion valve. Okay, we have not given the refrigerant to enter, and before that it is cooled by 5 degrees Celsius in heat exchanger, and simultaneously the refrigerant is superheated after leaving the evaporator. Have you got this line?
Yes, sir.
Huh?
Refrigerator with the heat exchangers.
Refrigerator VCRS with regeneration, right? Have you got? What happens
Yes.
in regeneration? I will show again. See here, what is happening here? This is the exit of the condenser before it is the, this is the entry to the expansion valve. So in exit of the condenser is going first through the heat exchanger, and then it is entering to the here, and same this gives heat to whom? It is giving heat to the, when refrigerant exits from the evaporator and before entry to the compressor. After going from here it is entering to the compressor, right? Am I clear or not?
Yes, sir.
Other clear for others or not? Hello.
Yes, sir.
So what is that problem? They have said after exit from condenser it enters to the heat exchanger, and it gives heat to the refrigerant that exists from evaporators, and then it will enter to the compressor. So what main thing I have told you to learn from here, remember from here? So amount of heat what it will give, this refrigerant will give to this, that would be the same, not the degree of subcooling or superheating. Amount of heat would be the same, but degree of superheating or some cooling might be different. Can you tell the reason why?
Space.
Different of the specific heat.
It is written here, right? So because the here it is liquid, specific heat of the liquid for refrigerant might be different from the, might be, it would be, so it would be different from the vapor. Okay, so that's why degree of superheat might be different. Degree of superheat, here degree of superheat for this and degree of subcooling for this would be the different. This you keep in mind, then only you can solve this problem. Now read. Okay, so here it is subcooled by 5 degrees Celsius in a heat exchanger before entering to the expansion valve. Now this line is clear or not? Hello.
Yes, sir.
And simultaneously the refrigerant is superheated after leaving evaporator. They haven't told how much superheating is there, right? That you have to calculate. How will you calculate? That hint I have given there just now. Assume the single cylinder operating at 1000 rpm with stroke is 1.2 times the bore. You have to calculate two things: power required and the cylinder dimension. How will you find the power? Refrigeration effect you have you will be knowing. COP only you need to find, then refrigeration effect by COP would be the power, right? So you have to find the COP. So first of all you need to find what is the cycle here. Correct or not? Hello.
Yes, sir.
First let me know, is it tough for all or what? So if it is tough, then I can switch to other problem, or I can tell the regeneration cycle again.
No, okay, sir. Continue.
Right? Clear now?
Yes, sir.
You have to respond, otherwise I have to switch. Okay. So I am making the cycle first. If no any problem is there, let me know. Okay.
Sir, in the table, CP last two column
Mm-hmm.
titles the same.
Oh, okay, sorry. This is 1 minute. For vapor it would be less. This would be vapor. Okay. Any mistake other? Okay, other is fine. TS diagram I am making first. So it works between -10 and 35 and NH3 as a refrigerant. First see this cycle. How I made this? Is it clear, right? Is it clear to others how I made the cycle in the last class?
Yes, sir. Clear.
I will repeat. So 1 minute. It is 4 days. So here what happened? A refrigerant will first of all you have to see. I will repeat here again, just listen carefully, then only you can understand this and then we can solve the problem. So here what is this? Here refrigerant exits from evaporator and it enters to the heat exchanger. Okay. And simultaneously see from here exit of condenser, it is the third point. Third point is what here? This. Right. And first point is what? First point is this. Okay. First point is exit of evaporator and just entering to the heat exchanger, means this is the first point and this is the third point. So from both side, from here hot fluid will be coming. Hot fluid, why hot fluid? This temperature is high and this temperature is low. So low fluid would be coming from this way and high fluid would be coming from this way, right? So a high temperature fluid, low high means it is related to temperature. So if low temperature will going from here, hot temperature, hot water would it refrigerant would coming from here. So temperature of the this hot refrigerant would keep will be reduced. So that's why 3 to 3 dash. 3 dash is what? Exit to the heat exchanger. This is 3 dash, right? Is it visible to you or not?
Visible.
So this is 3 dash. This is the 3 dash, and its temperature got reduced. Same way, the temperature of this cold refrigerant would got increased due to it because it will take heat from here. Its temperature become 1 dash. So this temperature is 1 dash, right? So its temperature got increased. Now 1 dash would go to the compressor and we will be compressing it from 1 dash to 2 dash. Let's suppose this is 2 dash. From 1 dash to 2 dash would be compressing. So here we are going to give work 1 to 2 or 1 dash to 2 dash.
1 dash to 2.
So these mistakes you would be committing while solving the problem. So that's why keep in mind. So this would be the work input because you are going to find the COP, right? So this would be the work input. Now from here it will get compressed. Okay. Then it will come to the condenser from 2 to 2 dash to 3 it will come, and this is the 3. Again it will its temperature keep down because of the in this heat exchanger. This is 3 dash. What is entering to the expansion valve, 3 or 3 dash?
3 dash.
3 dash.
3 dash.
So 3 dash would be this, and exit to the expansion valve is 4 dash. So 3 dash to 4 dash. This is the exit of expansion valve, and exit of expansion valve will go to evaporator. So what would be the refrigerating effect?
H1 dash minus H4.
Why H1 dash? H1 is here, H1 dash is this. From evaporator, how much enthalpy it has been taken from the cooled space? H1 minus H4, right? Sorry, H1 minus H4 dash.
Yes,
This
sir.
is H3 dash, this is H4 dash. So refrigeration effect would be H1 minus H4 dash, right?
Okay, sir.
So keep this in mind. Same cycle I am going to make there. You have to calculate those values. Okay. Now is it clear to not clear or not this cycle? Hello,
Yes, sir.
this cycle is clear to everyone or not?
Yes, sir. Yes.
Clear, sir.
Because here also you have to find a lot of values. Okay, so lot of places would be there, so there you would be mistakes, committing mistakes. These other values you have to keep in mind, which you have to find. Okay, others I am making only for reference. This is 4, this is 4 dash, this is 1, this is 1 dash, this is 2 dash, and this is 2, this is 3, this is 3 dash. Okay, this way represent will flow. So first let me know what would be the refrigeration effect in terms of enthalpy here. Can anyone tell? H1 minus H4 dash, right?
Yes, sir.
So what would be the power input, energy input I can say?
H2 dash minus H1 dash.
H2 dash minus H1 dash. Okay, now we'll start. Okay, which values we knows, that we'll try to find first. Okay, what is given here? It is subcooled by 5 degrees Celsius. What is subcooled?
In exchange, heat exchanger, sir.
This value would be cooled, right? Means exit of the condenser would be get cooled from 3 to 3 dash. What is the temperature difference?
5 degree.
T3 dash, T3 dash would be less, right? So it would be the 5 degrees Celsius, right? Hello.
Yes, sir.
So whatever in heat would be there, this is given to this part, right? Is it clear?
Yes, sir.
So this is the liquid here. Here liquid is there, here vapor is there. So you know the value of H1. What is H1? What is H1?
1450.
0.22 kilojoule per kg. I am solving this problem very slowly. Okay, so you just keep pay attention here. I'm not going. I will not be rushing in this problem. So H1 is this, and how will you find H1 dash? Can anyone any idea?
We will calculate temperature of one dash and then we will add it to Hg.
So how
Possible heat.
what would be the enthalpy associated with this part? Same enthalpy would be transferred to from 1 to 1 dash, right?
Yes, sir.
So
CP liquid into temperature change.
so what is the Cp of liquid for this?
4.556.
Means H3 minus H3 dash would be equal to the H1 dash minus H1, right?
Yes.
So can you let me know what is the value of H1 dash here? Okay, step by step. What is H3 minus H3 minus H3 dash? Cp of liquid, because here it is liquid and at the temperature of this 35. this pressure. So Cp of liquid is this. So this would be the Cp into T3 minus T3 dash, and T3 minus T3 dash is given as 5 degrees Celsius, right?
Yes, sir.
So H1 dash minus H1 is you can find. So Cp of liquid you knows. So can you let me know how much it is coming? Cp of liquid is this. Just multiply it by 5.
22.78.
22.78 kilojoule per kg. Okay. So what is the H1 dash from here? Because we know the value of H1. H1 is this. So H1 dash we can find, right? Just simply add this. Means, okay. Let me know the value of H1 dash. Hello?
Yes, sir. 1511.
What?
1511.3.
No. Why? This is 1450. This is 22.78. Just simply add.
1473.
1 4.
7th.
Okay. This would be, yeah, fine. 1473 kilojoule per kg. Correct?
Yes.
Yes, sir.
So we know the value of and can you let me know the what is the temperature for T1 dash? Hello.
Yes, sir. The heat gain in subcooling. Subcooling equal to Cp of vapor into T1 dash minus T1.
Simply here Cp of vapor. Vapor of what? Which vapor? This vapor or this vapor? Upper or lower?
At minus 10 degrees centigrade.
This Cp of vapor you have to use. Okay. Cp of vapor, and here T1 dash minus T1. Everything you know, just simply let me know the value of T1 dash. What is T1? T1 is this. Keep this in Kelvin. Sorry. This. So what is the T1 dash from here?
Two 272.14.
What is 272?
0.14.
I think it should be different. Is it same for others?
Yes, sir.
Okay. So this is the T1 dash. So in order to find the value of H2 dash, so what you have to do? Can anyone roughly can let me know? Just think and let me know what you will do. You know the value of temperature only here. One dash temperature only you knows. Everything property of one dash you know everything, right? Enthalpy, temperature, entropy, you can get everything. So in order to find the enthalpy of this, what will you do? And you know the property here, right? At the saturated curve you know property.
Yes, sir. S1 dash equal to S2 dash, sir.
S1 dash is equal to S2. 1 minute.
At the S1 dash is getted from the
अब बताओ. एक मिनट. हाँ ठीक. नहीं, एक लास्ट क्वेश्चन करा रहे हैं, सिम 15 मिनट करा के आ रहे हैं 10 मिनट में. हाँ ठीक. हेलो.
yes, sir.
1 minute. So you are saying S1 dash would be equal to the S2 dash, right? So if you will get the S2 dash, then from that you can get the temperature of here, right? Then if you know the temperature, then simply temperature difference with multiply with the specific heat, you can get the enthalpy here, right? Sorry, entropy. We will go step by step, then it would be better. So you said S1 dash would be equal to S2 dash. So do you know value of S1 dash?
Sir, Sg plus Cp ln of T1 dash by T1.
Means S1 dash minus S1. S1 dash minus S1 means from here to here, right? It would be the Cp of vapor at minus 10 into, sorry, ln T1 dash by T1, right?
Yes.
So from here, what would be the S1 dash? It would be the multiply of S1. Sorry, not multiply, addition of S1. S1 is what? S1 we knows, right? This is the value of S1. Sg value at minus 10 degrees Celsius, right?
Yes, sir.
So can you let me know what is S1 dash? CPV at that minus 10 is this. And T1 dash, we know this is the T1 dash, and the T1 we know T1 is this. This is 263, right? Calculate it and let me know.
Yes. 5.84.
Yeah, how much it is?
5.848.
5.84, right? Others the same, right? Hello.
Yes, sir.
Okay. Now you know the value of S1 dash. It is same as the S2 dash. Correct?
Yes, sir.
If S1 dash is equal to S2 dash, then you have to find the enthalpy of S2 dash. How will you find the enthalpy? Enthalpy you can find only when you know the temperature of that point. So how, if you know the entropy, then how will you find the temperature of that point? Can you find the temperature with this value of S2 dash?
Yes, sir. S equal ds equal to dq by t.
Let's suppose this is point B. Okay. So S2 dash minus S of B would be equal to Cp of vapor at the rate, sorry, oh, Cp of vapor at the rate which temperature? 35 degrees Celsius of ln, and then T2 dash
tb.
Tb. Okay, and SB we knows. What is SB? This is SB, right? Correct?
Yes, sir.
So can you let me know what and S2 dash is this? We know everything. S2 dash, SB, CPV, and TB. What is TB? TB is this. Means 308. Right? So let me know the value of T2 dash. Hello.
Yes, sir.
Is it 382.83?
How
Yes,
much?
sir.
382.83.
Sir.
Okay. Is it same, right?
Yes, sir.
Now you know the T2 dash and TB you knows. How can you find the enthalpy of H2 dash? Any idea?
Yes, sir. Hg plus
Yeah.
Hg plus Cp T2 dash minus Tb.
H2 dash would be the H of B plus Cp value is we know. What is the Cp value of vapor? This, right?
Yes, sir.
Uh,
2.90.
2.903 and what is the temperature of this minus temperature of this? Sorry, temperature of T2 dash minus temperature of TB, right? Means 382.83 minus 308. So what would be the answer? That would be the H2 dash. Can you let me know?
One 1708.
How much?
1708.
Okay, fine. Now we knows the value of H2 dash also. Enthalpy values I am putting under brackets, so later it would be better to collect. So H3 is what? H3 we already knows. HF this value, right? 366.07 kilojoule per kg. Correct? Hello.
Yes, sir.
And how will you find the H3 dash?
H3 minus Cp of
H3 minus simply we can subtract this, right? This value, right? Same, because this is same as this. Enthalpy difference of this value is same as the enthalpy difference of this value, correct? And this we have already calculated. Cp of temperature, Cp of liquid of this temperature, this pressure, and into the temperature difference, right? Hello. This 22.78. What is
sir,
this? This is same as the difference of this value, right?
343.3.
How much? 3
43.
point.
3. Sir.
Okay. Now we know the value of H3 dash, and H3 dash is same as H4 dash, right? Correct? Now we know the value of everything. Now we can find the COP of cycle. Right? What is the COP of cycle? H1 minus H4 dash divided by H2 dash minus H1 dash. Now we know the value of H1. What is the H1? This is the value of H1. And what is the value of H4 dash? This is the value of H4 dash. This value. And what is H2 dash? This is H2 dash, this. And what is the H1 dash? Here we have calculated. So can you let me know the what is the COP? First tell me H1 minus H4 dash, what is it is coming? Hello?
1106.92.
1106.92. So next this H2 dash minus H1 dash. H2 dash is this value and H1 dash is this value. I think it is 235, right? Is it right?
Yes.
So divide it and let me know how much it is coming.
4.7102.
4.7102.
02.
Okay, this is the COP of the our cycle. So what would be the power input? Can you let me know what is the power input? First question of this problem is power input. Power input. Power input, the refrigeration effect is 50 kilowatt and the power COP is the 4.7102. So how much it is coming? Hello? Hello? Am I audible? Hello? Hello?
Yes, sir.
Yes, sir.
Sorry, I think my network got disturbed. So where are we? Power input, right?
Power input.
1 minute.
10.6150.
10.51.
10.516 kilowatt. So this much power we have to require to run this compressor. Now next is the dimension of the cylinder dimension we have to find. So any idea for this, because this is the first problem we have got of this type, right? Because COP and all we are finding from 3-4 problems we have did, but any idea how we can go start?
By finding mass.
I think again my network is unstable. Am I audible clearly?
Yes, sir.
Your voice is breaking when I am
Yes,
hearing.
sir.
Okay, so one minute. Can anyone tell what is the volumetric efficiency formula?
One minus C into
Next,
P2 by P1 whole power 1 by N minus 1.
minus 1. Okay, can you use somewhere this here, right? You can use or not? Do you know polytropic constant here?
Ah, yes, sir.
Do you know? Do you know this
Isentropic,
C? Do you know C? What is C?
isentropic compression index.
Okay, here you can write 1 by gamma. Okay, what is the value of C will you use? What is this C? Is it are you able to remember what is the C?
Clearance ratios.
Clearance ratio, right? So do you know here? Here it is not given, right?
Sir, screen not visible, sir.
Oh, sorry.
Screen not
Sorry.
visible.
Oh, I haven't shared it.
Stroke volume length and bore length.
1 minute, 1 minute. From start, I haven't shared the screen, right? Hello.
Yes, sir.
From how long I am not sharing the screen?
Ah, yes, sir.
Then you disconnected.
Okay, okay. So here nothing about this clearance ratio is given. So if nothing is given, so that time we are for theoretically we are solving. Okay, if somewhere 1 minute, what is this? Here no, if somewhere it would be mentioned like clearance ratio is 3% or 10%, then we would be using this formula. Okay, like in next problem I would I would be giving that problem to you for homework, and next class in the start of class we will solving that problem. There it is written like clearance ratio is some percentage there it is given. I can't remember. I think 3 or 5% is there. So this P2 and P1 you would be knowing what this is. P2, right? This is P2 and this is P1, correct? So this you know, and everything then you know. If you know C, P2, P1, then this volumetric efficiency you can calculate. But here it is not mentioned, so we would be taking this as 1. Okay. So whatever dimension of the cylinder we are calculating here, that would be known as theoretical dimension of cylinder. Theoretical dimension of cylinder. Okay. So another formula of volumetric efficiency I have told. What is that?
Mass flow rate into
Mass flow rate into
V1
V1 is what? V1 is what? What is this?
inlet to the compressor.
Okay. Here what is the inlet to compressor?
V1 dash.
V1 dash. Do you know V1 dash? No, as of not, no. Then we have to calculate with this, right? This is the VG is this V1, and this is the constant pressure process. For the constant pressure process, you can find this. That we'll see. But here first we'll write. This is m dot V1, and then what this
Pi by 4 T square into L.
pi by 4 d square L. What this shows? Pi by 4 d square L.
Shaft volume.
This is swept meter cube per revolution means it will show. So n is the RPM. Okay, and number of cylinder here it is given, right?
One.
Where it is single cylinder, right? So n would be the number of cylinder, k would be 1. So have you calculated what is m dot? Anyone calculated it? How can you calculate? Refrigeration capacity equal to m dot into H1 minus H4 dash. H1 minus H4 dash. Can you let me know what is m dot here?
0.045.
0.045 next. After decimal, try to tell answer till 4 places. Okay.
452.
Okay. Kilogram per second. So it is in per second, but here downside when we calculate this, this is a revolution per minute, and this volume total volume, theoretical volume would be in the meter cube per minute. But when we calculate it, so it should also be in kilogram per minute. Okay, because it would be the kilogram per minute, and this would be the meter cube per kg. Then only both unit dimension would be the same, right? So what would be then per minute? This would be mass flow rate.
2.71
kg per minute. So volumetric efficiency we are considering as 1. M dot we knows 2.71. V1 dash we don't know. That we'll see. And pi by 4 we knows. Here it is cylinder operating at stroke is 1.2 times of bore. It is written here. So here stroke is what? L is 1.2 times of diameter. So pi by 4 d, first we are calculating d. So L we write as 1.2 of d, and n is given, right? What is n? 1000. Now it is only required to find the V1 dash. So this is the, let's suppose this is the only 1 dash, and this is the 1, and here we know the value of V1, and this is constant pressure process, and you can find the V1 dash, right? How can you find? V is directly proportional to T for the constant pressure process, right? Hello.
Yes, sir. Yes, sir.
So V1 dash by V1 is equal to T1 dash by T1. We know everything here. V1 we knows, T1 dash we knows, T1 we knows. What is the value of V1 dash from here? Can anyone tell? This is the value of V1. This is right. Specific volume at 1 means at the saturated vapor of the minus 10 degree Celsius. This is the value, right? So 0.41749 ratio of What is the T1 dash? Can anyone tell? $272.14. And what is the T1? 263. And what is the V1? 0.41749. 0.41749. Can you let me know what is the V1 dash?
Is it
0.4320.
0.41749 is V1. Okay. How much someone has told? How much it is?
0.4320.
Is it correct, sir? 0.4324 meter cube per kg.
So we can write this here 0.4320. So can you let me know what is the value of D from here? Quickly tell. Hello.
0.107 meters.
In mm it is, right?
107.53.
What is the length?
129.
So this is the theoretical dimension of our cylinder, right? Hello. These are the theoretical dimension of our cylinder, correct or not? So this problem is a big, but you might our aim is my aim is like to how to solve uh, various types of problem. I don't think apart from that anything will come. Okay, only cascade problem is remaining, and one problem where clearance ratio is given, that is the next problem. I think I will give that for homework. You try, if any problem is there, next class we will solve. And if in between you want to discuss anything, I will put my mail ID here, and you can drop mail, I will respond there. So I think this is big problem. So if any problem is there, I will just upload this on the YouTube by tonight only. So there you can quickly see. If any doubt is there, in some other doubt, then you can ping me. I can share my email ID or WhatsApp number, anything. So just ask me whatever is there. Okay. So if any doubt for this as of now, can let me know, otherwise okay. So this problem I will quickly tell the hint, and you try. So food storage requires refrigeration capacity, it is given in TR. So first you have to convert that into kilowatts. So this temperature range is given. Temperature of refrigerant superheated as temperature of the refrigerant superheated as gas in an evaporator is -5 degrees Celsius. Okay. So here temperature is given, means there what we have calculated T1 dash, that is given here. Okay, correct? Is it clear or not? What is -5 degrees Celsius? Because here T1 is -10, so it is superheated. This value is given is this. So and the temperature of the refrigerant subcooled as liquid in condenser is 25 degrees Celsius. Here it is 30 and it is subcooled to 25 degrees Celsius. Number of cylinder 2 given. Stroke is 1.5 times of bore, and speed is given this. Then first you have to find the refrigeration effect and mass flow rate, theoretical piston displacement. What do you understand by theoretical piston displacement? Can anyone tell?
Swept
Shaft
volume.
volume.
Not swept volume. Displacement means you have to tell the length of the piston, but considering the volumetric efficiency as 1. Okay. Theoretical it is written here. That is the main theme. Okay. You have to calculate the dimension in short and consider the volumetric efficiency as 1. Okay. And COP also, and in the second part clearance volume is given as 3% of stroke, right? Hello.
Yes, sir. Yes, sir.
So value of C is 0.03. So then some volumetric efficiency will come, and P2 and P1 P2 is given. So find the first volumetric efficiency, and then first problem is this only, find the volumetric efficiency, and then is the bore and stroke of the compressor. Same dimensions you have to find considering the volumetric efficiency. Is it clear?
Yes, sir.
I think you have to give a try. Answer is different thing. I will let you know the answer. First main theme is you have to give a try. Okay.
Sir, in the table, that V specific volume, is it for liquid?
No sense for liquid. It will be for vapor only.
Okay.